This is part 4 of our lesson on operations with logarithmic functions. In this question, it says for the functions c of x equals 4 log base 6 of x plus 1 minus 3, and d of x, which is 3 times log base 6 of x plus 1 plus 8, we want to determine a simplified expression for c minus d of x, and then we'll do c times d of x. So for c minus d of x, that means c of x take away d of x. So I am going to take the expression for c of x, which is 4 log base 6 of x plus 1, take away 3, and I'm going to put that in for c of x. So this is 4 log base 6 of x plus 1, take away 3. Now this has two terms. Terms are separated by pluses and minuses. So the first term is 4 log base 6 of x plus 1, and then our second term is 3. So since it has two or more terms, that really needs to go in a bracket to show that those are together. And then we are taking away d of x, which is 3 times log base 6 of x plus 1 plus 8. And once again, this has two terms. There's a plus sign here. So 3 log base 6 of x plus 1 is the first term, and 8 is the second term. So if it has two or more terms, it really needs to go in a bracket. So our first bracket, there is nothing in front that we are multiplying by. We are not dividing by anything, and there isn't a minus sign in front. If anything, there's just a secret little 1 in front that you can multiply the terms by. And this just works out to be 4 log base 6 of x plus 1, and then minus 3. The second bracket is not really being multiplied by anything, but does have a minus sign in front. So I can't just eliminate the bracket. What we need to do is either subtract each of the terms or put in a little secret 1 and then multiply each term by -1. So I am subtracting 3 log base 6 of x plus 1. And then we are also subtracting 8. So that's going to be minus 8. Or if you think about it, -1 times 3 is -3, and then -1 times 8 is -8. From here, we are looking for like terms. There are some easy ones to spot. The numbers 3 and 8 are absolutely like terms. The trickier ones are the logs. I see that this is log base 6. This is log base 6. This has an argument of x plus 1. This has an argument of x plus 1. This has no exponent that I can see. This one has no exponent that I can see. So they are like terms. So I would just do 4 log base 6 of x plus 1s, take away 3 log base 6 of x plus 1s, and I get 1 log base 6 of x plus 1. If you want to put the 1, that's great. Otherwise, I'm just going to write log base 6 of x plus 1. And then -3 take away 8 is -11. Now, I do want to point out, just really quickly, that you could use variable replacement here. So we talked about variable replacement with trigonometry. We said, especially if you have like terms, you can take out the trig, or in this case, the log, and let it be some other letter of the alphabet. So I could have let a equal log base 6 of x plus 1. So I'm going to take the log with its base and the argument. And if I make that a, I would just end up with 4a, take away 3, minus 3a, take away 8. And then that is a little easier to work with, right? I can more easily see that 4a and 3a are like terms. So that would be 1a, and then -3 minus 8 is -11. And then all you would have to do is just put the log base 6 of x plus 1 back in, and then you'd have your answer. So if you want to do the operations with the logs, do it. And if you want to do some variable replacement, do it. It is your choice, right? You get to decide what you're more comfortable with and then find something that works for you. Okay, we're going to take a look at B. So for B, I have C times D of X. So we're taking C of X and D of X, and this time we are multiplying. So this is C times D, sorry, C of X times D of X. C of X is 4 log base 6 of X plus 1 minus 3. That needs to go in the bracket to show that those two terms are together. And then we are going to multiply by 3 log base 6 of X plus 1 plus 8. Now, same thing as with the addition and subtraction, you can use variable replacement. And I actually, when you're doing multiplication, might suggest that. You're welcome to do the distribution with the logs, but sometimes that gets a little bit complicated. So I might be inclined to let A equal log base 6 of X plus 1. So I don't include an exponent on the log. I just take the log with the base and the argument. That's it. That's what I take out. So this is going to give me 4A minus 3 times 3A plus 8. And then this is just a simple polynomial multiplication question, right? We are going to distribute or use FOIL. We're going to do 4A times 3A. That is 12A squared. 4A times 8. That is 32A. Negative 3 times positive 3 is negative 9A. And then negative 3 times positive 8 is negative 24. All right, if I collect up my like terms, I have 12A squared. I have 32A take away 9A. Those are like terms. So I get 23A and then minus 24. Right? Once you've multiplied, collected up your like terms, all I need to do is take out the A and put back in log base 6 of X plus 1. So this is going to equal 12 times A squared. So that is log base 6 of X plus 1. And then the place where we put the square, either you put a bracket around the log and then a square, or we sneak the square in between the log and the argument. Right? And then we're going to do plus 23A, or 23 times log base 6 of X plus 1. And then minus 24. Nothing to sub in there. So my final answer there is 12 log base 6 of X plus 1 all squared plus 23 times log base 6 of X plus 1 minus 24. And that's going to do it for question number 4. I will see you in the next video to look at how to do question number 5.